Hi, Mike here. You're watching Scout Restoration Yukon. In this video, Engine Hookup 1, I finished installing the clutch linkage cross shaft, connect the choke and throttle, install extra ground straps, connect the alternator, replace the voltage regulator, starter wire orientation, confirm sender wires to gauges, diagnose and repair wiring to coil. Bonus, how to check amp draw with a test light. I will show all the details. I hope you like it. If you want to help, please subscribe to Scout Restoration Yukon. It's free. Mike Morrow, over and out. Hi, Mike here. You're watching Scout Restoration Yukon. In my previous video, I installed the engine in the Scout. But I've been tinkering on it and looking around, trying to find everything, because not everything was there when I acquired the Scout, and some of it was actually the wrong stuff. Let's have a look. So I already put the fan back on and the pulley on the crankshaft for the belt. So I've got this clutch cross shaft bolted back on, and I figured out how it goes onto the engine. So at the end of the cross shaft, the long bracket on the swivel here goes this way, and it utilizes the same bolts that hold the coil bracket. The clutch linkage goes from here, which will be in behind the fuel pump, to here on the bell housing. So you can see here I've connected the choke cable, the throttle linkage, and the throttle cable, and I fabricated a little bracket here to hold the cable sheath for the throttle cable. So now I'm going to go underneath the Scout and connect a ground wire from the bell housing to the frame of the Scout. So I'm putting one bell housing bolt through this cable, and so it will go from this bell housing bolt, this ground strap. So I'm going to bolt that to the frame right here. I have to remove some paint so they can make an electrical contact. Looks like I got some good bare metal there. And then I've got a nut and a bolt. So I just put this cable under there. A flat washer, a lock washer, and a nut. Well, that's good and tight. Just going to tighten up the bell housing bolt. Put a snipe on there. There. That's good and tight. The first thing I want to do before I connect the battery is make a bunch of extra ground straps from the body to the frame and from the frame to the engine. And I already did one from the frame to the engine. So I'm putting flux on there, and I'm squeezing it into here, putting it into there, this end on, and I'm giving it a squeeze with the vise, like that. That's pretty good already. And now I want to solder it. So I'm going to put this between these two pieces of wood, like that. Put it in the vise. Acid flux. I'll try getting a little bit of solder in here. Of course, you're going to melt the insulation, but I'll deal with that later. Just got to get this hot enough. You can see the flux bubbling out of there now. Now it's sucking the solder in. So I got some good solder in there. And squeeze it one more time. I'll go dip it. So I'm just taping that up nicely, as tight as I can. So here you can see I've connected a ground strap from the firewall to an intake manifold bolt. This ground strap here connects the frame to the inner fender. Another ground strap here connects the frame to the body. So now I'm installing the alternator. Bracket goes here. Nut in the lock washer on the long bolt. There we go. I got the belt on here. So that'll be 1/2 inch. So just get a big screwdriver. Okay, and then 2 9/16. Two 9/16 wrenches here and here. That's tight and that's tight. Can actually turn the engine on with the belt. I'm just putting some dielectric grease in the plug here. And that, of course, plugs right in here. Like that. Make sure it's tight. These wires here go over the other side of the engine. Like so. The heavy wire goes here. Like that. And the lighter wire goes here. Yes. Needs some tape. Okay. So I'm going to tape that again. Okay. No. 5/16. Tighten. I always tighten the inside nut because you see that one was loose. Now I wonder about that inside nut. The other one was loose. I might just go get a little socket and double check that nut. Just double check that nut. See, I got a little bit on it. So it's a good thing I checked it. This guy goes here. Nut goes here. Just for fun, I can put a straight edge across these pulleys. Well, it looks pretty good. Attention, fellow Scout enthusiasts. Thanks for watching. I hope that you're getting useful insights from my videos. If I can earn 1,000 subscribers, I will be able to create Scout videos for a long time. Please like and subscribe so that we can continue this journey for years to come. I will show all the details. Over and out. So before temporarily connecting the battery, I checked for amp draw, and there was no amp draw. So I connected the battery, and there was some smoke coming out of the regulator. So I'm not sure if it was the regulator or the relay. So what I'm going to do is replace the regulator with this one, which is new. So the first thing I have to do is remove the capacitor from the old one and put the capacitor on the new regulator. Then You have to start somewhere. We'll start with the top screw here. Get that one started. Screw it in a bit. Then this screw here incorporates the relay. Let me get that relay on there. And the screw. And then this other screw goes through a ground wire, capacitor. So I clean the metal off to make sure I've got good contact. Tighten that screw, that screw, and that screw. Right. Now, be able to just plug that right into there. Okay. So far so good. I've changed that. Now, I'll just put the positive post on the battery. I'm going to check this test light. Lights up here. Doesn't light up here. According to that, there's no amp draw. So now, what happens if I connect the battery again? There. Just leave that for a minute. So I don't see any smoke there. Because all of this wiring is unknown. I don't know this vehicle. So it's not smoking. So the other regulator must have been defective. So the next thing I wanted to do is check these starter wires. So the white wire down here is going to this red one. So I've got the test light on ground, right? Red wire here. Right. So that's the white wire, which I think should become hot when I go to the start position on the key. So let's just see. Yes. You see that? So that's just when I go to start. Right? So that goes to the S terminal on the starter solenoid. That's the top small terminal on the starter solenoid. So that's one wire sourced. Now the other wire here should have power in the start position because it gives the coil a full 12 volts when starting. The other wire goes from the other terminal on the solenoid to the coil. So now when I put this in run, it comes on. Not start, run. So this wiring harness is wrong. There's one wire doing two things. The one wire is key on hot, which it should be supplying power to the input side of the resistor that will get knocked down to 9 volts by the resistor. And the other wire, which comes from the R terminal on the starter, right, should only supply 12 volts when the key is in the start position to give a boost to the coil, a pure 12 volts, because cranking voltage is only about 9 volts, right? And the other wire goes through the resistor, knocks it down to 9 volts to protect the coil and the points from overheating. So I figured out what happened. Somebody built this harness, and they've put those two wires together. That's why I have one wire doing two things, right? So what I have to do is run a separate wire from the starter, incorporate it into my harness, and that'll solve all the problems. And that'll give me my booster voltage on start, right? So let's get to work. So now I've disconnected all the wires, and I've disconnected the starter wires and brought them over to here. So this is the wire here, the green wire that goes to the starter and should only give power when the key is in the start position. And this one here is the wire that goes to the coil, and it has power with the key in the run position, right? And it also has power with the key in the start position. So that means this wire has been spliced onto this wire. And to confirm that, I can just confirm that with an ohm meter right now. Here's my ohm meter here, and here's the wire that goes to the coil. I have the other terminal, it's on the starter wire, right? So now, you see, I have continuity, and I should not have continuity. So, my solution is to run another wire to eliminate this wire here that was going to the starter and run a separate wire. So I'm going to cut this wire and just tape it back, delete it. So all I have to do now is run another wire from the starter, bottom terminal on the starter solenoid, to the positive side of the coil after the resistor. So let's get to work. So I taped back the green wire and I replaced it with a blue wire, which goes all the way from the starter to the positive side of the coil. This will do the job of giving the full 12 volts when in the start position. So I'm going to disconnect the battery, negative, and then I can install those two wires. So I'm connecting the white wire to the top post on the solenoid. There's the wire on there, the lock washer. Go here with a little 11/32 socket. That's tight. I don't really like the way those starter wires are orientated. So I'll loosen that off. Here. Tighten that up. That. Then you go underneath and put the bottom wire on. There we are. Underneath. Another wire. Tiny little lock washer. Tighten that up. So the starter wires are connected. So now we've got the battery connected. The key is in the run position. The meter's set. Now this is the wire to the oil pressure sender. To connect that, and if I touch ground over here, you see what I have? I have a pulsating voltage to 5 volts. Okay? That means I have a complete circuit to my gauge. This one is the temperature sender. Here, this is the temperature sender. I'm going to do the same thing, right? Put the wire on here, touch the ground, and you see I have pulsating to 5 volts here. So that means that circuit is complete. So I can connect both of these things. Now this is the coil wire. Here. Goes to the resistor on the coil. And how many volts do I have here? 11.75. If I check my battery voltage, right? Because there's supposed to be a resistor, inline resistor. So I have to check that again. But if I check my battery post, okay, that's what I have is 11.78. So I should charge this battery. So I've got battery voltage at the coil. So I'm just doing a little bit of taping This one here, I have to keep it separate because it splits off. I'm just going to tape that. Tape up this connector, this butt connector. Alright. Then I'm going to continue up here. Should go here on this side of everything like that. Temperature sender unit. It's kind of short, this wire. I don't like this wire. I think I'm going to redo this wire because if I want to remove the valve cover, it's in the way. So I'm going to redo this wire and make it longer. So much for that. It's too short. And bring all of this back through here. Better get the tape off of there. So I lengthened the wire to the temperature sender. And I was able to run the wires around in behind the dipstick tube, right, and up through there, so they don't interfere with removing and replacing the valve cover. And then they go down through here on the inside of the distributor, right? They come out over here. So I attached the wire to the oil pressure sender. I lengthened that wire too, and it runs through the back of the coil bracket. So everything's kind of nicely out of the way. And I'm not going to finish modifying the coil wires until I get my new coil. So far so good. I've replaced the defective voltage regulator with a new one. I have a rebuilt alternator that's exactly the same as the original alternator that the Scout came with. I've connected my starter wires, and I've determined that the temperature sender wire and the oil pressure sensor wire are connected to the gauges from the engine department. So that's pretty good. I just wanted to show how I'm checking amp draw, because my multimeter, the amp part of my multimeter is blown, so I can't use that. So what I'm doing is I'm using a test light, which isn't very accurate. It's not quantitative, but it'll let you know if there's a draw. It won't let you know if there's a very tiny minuscule milliamp draw, but it'll let you know if there's a draw. And this is perfect for my purposes at the moment as I connect things, unknown things to this electrical system. Every time I do that, when I reconnect the battery, I check the amp draw. That's a very good way for me to avoid some kind of catastrophic electrical problem. So here's how I do that with a test light. This is the negative terminal of the battery, and this is the negative cable, which is not connected. So now, if I connect the positive, and so I can go from the negative to the positive, you can see my light is lighting up, right? But if I go from the negative to the negative, right, the light doesn't light up because there's no amp draw. Now I'm going to go and turn the key on. So now the key is turned on, right? And if I touch here, the light lights up because there's an amp draw, right? This is all I need to know. So if this was doing this, I wouldn't connect the battery until I found out why. So why is this light on? Because the key is on. I will go turn the key off, and now there's no draw. The light lights up on the positive, but there's no draw, right? So for the entire job, every time I do something, I change something on the wiring on the Scout, I do it with the battery disconnected. And before reconnecting the battery, I quite simply use my test light to check for amp draw so I won't have any problems. And just disconnect this battery completely. Good to go. In conclusion, the engine hookup is moving along. I'm solving problems and confirming electrical circuits, methodically repairing and adjusting. So far, so good. In my next video, Engine Hookup 2, I check grounds for continuity, install a new coil and ballast resistor, and new spark plug wires. As a bonus, I check for spark. I will show all the details. I hope you like it. If you want to help, please subscribe to Scout Restoration Yukon. It's free. Mike Morrow, over and out.